The background of our study. Metabolic syndrome is a condition that includes a cluster of risk factors specifically for cardiovascular disease. It increases the risk of developing diabetes, heart disease, or stroke. Some factors that can cause metabolic syndromes include abdominal obesity, high blood pressure, impaired fasting glucose, high triglycerides levels, and also low HDL cholesterol levels. Most people who have metabolic syndromes also tend to have insulin resistance. The body makes insulin to move glucose into cell to use as energy. People with higher blood glucose level are more commonly diagnosed with metabolic syndrome, which makes it difficult for cells in the body to respond to insulin. If the body can't make enough insulin to override the resistance, the blood glucose level increases, causing type 2 diabetes. Metabolic syndrome is a serious health condition that puts people at a higher risk. Next is the objectives of study. First is to determine the relationship between metabolic syndrome and blood glucose level. Second is to describe the descriptive statistic of the metabolic syndrome and blood glucose level. Third is to obtain the type of graph that are suitable for the data. And fourth is to find the values of mean, standard deviation, and interquartile range. The significance of studies is to show the importance of taking care of one's health to avoid being affected with metabolic syndrome. If the blood glucose level increases, it will also increase the risk to be diagnosed with metabolic syndrome. The blood glucose level is positively correlated with BMI, which is also one of the causes of metabolic syndrome. Statistical evidence shows that such findings can aid people in understanding the effects of metabolic syndrome in daily life.
Methodology. So, the data description for this methodology is a sample of metabolism syndrome is occurred in the study, and this is a sample of the data identified as a quantitative data that includes two variables. As for the graphical technique are used to describe data, these methods may not always have explicit formula associated with the graphical representation. It is to provide valuable insight into the characteristics of data and relationships between variables, while the graphical representation itself does not have a specific formula. Highlight important features and the results which can guide decision makers to decide. And it is divided into two categories, which are qualitative data and also quantitative data. Graphical techniques are divided by two data, which is quantitative data, which refers to information that can be expressed and measured numerically, and qualitative data, which refers to non-numerical information that is descriptive in nature. These are the examples of graphical methods, which is the first one is frequency table and the second one is histogram. There are also frequency polygon graph and also octave. There are also numerical techniques, which is first is descriptive statistic analysis and the second one is correlation and regression analysis. As for descriptive statistic analysis, it contains mean, which is the average of a data set, and median, which is the middle number in a sorted ascending or descending list of number, and can be more descriptive of that data set than the average. It is also contain minimum value, which refers to the smallest numerical value within the set of data. It is also the data point that is lower than the other values in the data set. And it is also contain maximum value, which refers to the largest numerical value within a data set. And it is also a data point that is higher than all other values in the data set. And lastly, standard deviation, which is a measure of how dispersed the data is in the relation to the mean. Now we move on to the correlation and regression analysis. The first one, we have the Pearson correlation coefficient. It is often denoted as R. It's a statistical measure that quantifies the strength and direction of a linear relationship between two continuous variables, and it is ranged from -1 to +1. The second one, we have the coefficient of determination, which is often denoted as R2. It's a statistical measure that provides insight into the proportion of the variance in the dependent variable that is predictable from the independent variables in a regression model. And the last one, we have simple linear regression, which is a statistical method used to model the relationship between a single independent variable, which is x, and a dependent variable, which is y, by fitting a linear equation to the observed data. As we can see here, there are three different formulae that we can use in the correlation and regression analysis. The first one, we have the Pearson correlation coefficient formula, and then we also have the coefficient of determination formula, and the last one is simple linear regression formula.
Hi, my name is Arsha Sofia binti Rosizano, and I'm going to present about chapter 3, which is the results and interpretation. In this chapter, I'm going to talk about data presentation, descriptive statistics, analysis, and correlation and regression analysis. Based on this line plot, the y-axis is the metabolic syndrome and the x-axis is the blood glucose. The fit plot graph shows that the blood glucose is right skewed. A large number of blood glucose ascend on the right side and metabolic syndrome lines are not ascend on any side. Based on this table, the average level of blood glucose is 113.14 and the average metabolic syndrome is 0.37 with a sample size of 49. The middle value of blood glucose is 101 while metabolic syndrome is 0. The minimum and the maximum value of blood glucose is 80 and 258, while the minimum and the maximum value of the metabolic syndrome is 0 and 1. The value of the standard deviation of blood glucose is 39.62 and the metabolic syndrome is 0.49. Next, this is a scatter plot with a graph of the regression line. We can get that the equation of the regression line is y equals to -0.4188 plus 0.0069x. We can put an example of a prediction by using this equation. For instance, if blood glucose is equals to 100, we can get that y equals to -0.4188 plus 0.0069 times 100 equals to 0.2712. The value of the slope is 0.0069, and this highlights that for every increases of metabolic syndrome, the blood glucose will increase by 0.0069. Based on these regression statistics, the value of the correlation coefficient R is 0.565. So there is a strong positive relationship between blood glucose and metabolic syndrome. We also can get the value of the regression model, which is 0.3y94, and this means that 0.32% of total variation in metabolic syndrome count is explained by blood glucose count. Another 99.68% of the variation is explained by other variable.
From the data, we can conclude that the relationship between blood glucose and metabolic syndrome shows a positive correlation. An increase in blood glucose will also increase the risk of metabolic syndrome. And we also found that the graph that is suitable for this data is histogram. We also found that the mean is 113.14 for metabolic syndromes and 0.37 for blood glucose. The standard deviation is 39.62 for metabolic syndrome and 0.49 for blood glucose. For this data, the value of correlation is 0.565, which suggests a moderate correlation in relationships between the metabolic syndrome and blood glucose. The regression equation is y equals to negative 0.4188 plus 0.0069x. The value of slope is 0.0069, which means that for every increase in metabolic syndrome, the blood glucose will also increase by 0.0069.